Okay, the electrolysis of solutions of ionic substances. So obviously the substance has to dissolve in water, and when it does, the ions, the crystal lattice, the structure of the ionic substance is broken down, and the ions are free to move around inside the solution. So they're free and they can actually conduct electricity, move in charge, electricity. Okay, so if we've got a solution of sodium chloride, for example, we know that that solution is going to contain sodium ions, aqueous because they're dissolved, and chloride ions, aqueous. Okay, those ions are definitely present. We've also got to take into account that some water molecules will spontaneously break up to produce hydrogen ions and hydroxide ions. So every now and again, a water molecule will be given enough energy with collisions and whatever the situation is. Basically, they come together, these molecules, and every now and again, one of them breaks up in a collision. And you get hydrogen ions and hydroxide ions. Very, very few, but enough to be significant. So in aqueous sodium chloride, we've got a slightly more complex situation. Which anions are present? Well, anions, the anode is positive, so negative ions go to the anode. So which anions, which negative ions are present in this solution? Well, we have chloride ions and hydroxide ions. The cathode is negative, so positive ions go there. So which positive ions, which cations have we got in solution? And there you go, sodium ions and hydroxide ions. Now, when we pass an electric current through the solution, we need to work out what's going on. We need to explain it using chemistry, and also we need to describe what we see. This is kind of like the finished product. We've got an anode, and you can see yellow bubbles of gas coming from the anode, and we know that that is chlorine. Sodium chloride solution is the original solution, the electrolyte. Hydrogen gas, colorless bubbles of gas are formed at the cathode, which is hydrogen. And the solution that stays behind, it slowly transforms from being sodium chloride to being sodium hydroxide. Okay? That's the result of this particular setup. Let's try and explain that using chemistry. So, at the cathode, ions that go to the cathode, we've got hydrogen ions and we've got sodium ions going towards the cathode, but the hydrogen ions discharge. We'll talk about why in a minute. So two hydrogen ions gain 2 electrons to make hydrogen molecules. Okay, so we've got hydrogen molecules forming at the cathode. At the anode, the chloride ions discharge. So the chloride ions are attracted to the positive anode, and we saw this reaction before. We saw the equation. 2 chloride ions, each of them lose an electron, and a chlorine molecule is formed. Okay, so we can see that now. At the cathode, hydrogen is formed, and at the anode, chlorine is formed. If we've taken away the hydrogen ions and we've taken away the chloride ions, what's left? If you look back, the only 2 other ions that are present are sodium ions and hydroxide ions. So sodium hydroxide solution is formed. Hope all that makes sense. It's quite straightforward. It's a good idea to memorize these equations because they'll come up lots and lots of times. It's always the same equation. Whenever chloride ions discharge, it's always the same equation. Okay. How do we know which of the ions, if there's a choice, is going to discharge? We need some kind of series, don't we? And we're going to use this discharge series. So iodide will discharge before bromide, will discharge before chloride, before hydroxide, and then these ions down here never discharge. There's an extra point about the hydroxide. We've got to assume that all of these halide ions are concentrated. because if they're not concentrated, if they're very dilute, then some hydroxide ions may discharge. Okay, but we'll come back to that. Usually we're talking about concentrated halide ion solutions. And then copper ions will discharge before hydrogen ions, and you've got a discharge series there. Now, if you can remember your reactivity series, you'll see that the most reactive things are at the bottom here, and the least reactive at the top. And that's not an accident. It's like the reverse of the reactivity series. Okay? And just a little added extra here, something that we'll use more in the future, but it's worth you knowing this now. When a species gains electrons, we say it's been reduced. When a species loses electrons, we say it's been oxidized. And there's a mnemonic to remember this: oil rig. Oxidation is a loss of electrons and reduction is a gain of electrons. And they're just definitions, really. It's worth remembering them. Okay. Now, electrolysis of solutions is more complicated because you've not only got the ions from the ionic substance, but you've got the ions from water. But as long as you write down all the ions that you've got and you look at the discharge series, you can predict which of them is going to discharge and what's going to be left behind. We mentioned brine just now, and brine is concentrated sodium chloride solution. Typically you get this, you could use seawater, but seawater is a big mixture of other things. Typically you get it from salt beds, sodium chloride beds under the ground, and you'd pump very hot water into these beds and then suck it back out, and you've got sodium chloride solution, which is concentrated. To do this in industry, they use a diaphragm or a membrane cell. Okay, so there's this membrane or diaphragm in the middle. The reason why this exists is because if you're making chlorine gas and hydrogen gas, chlorine and hydrogen, if you mix them, they are explosive. So the membrane or the diaphragm is to stop the two gases from getting anywhere near each other. The membrane and diaphragm, it will allow ions to go through, but it won't allow these gases, these molecules to go through. So it separates them. So we put concentrated salt solution in, and we recycle it, use salt solution out, and that'll be recycled. On this side, the bottom right hand corner, sodium hydroxide solution comes out, and we put water in here just to keep the whole thing flowing. Okay, titanium and nickel cathode and titanium anode. I don't think you'll need to remember that, but it's worth knowing that they use different metals. Okay, so this process produces three very important chemicals. You need to know what they're used for. Hydrogen, typically making ammonia, making margarine and as a fuel. Chlorine, making bleach and for treating water. Chlorinated water kills the bacteria. And sodium hydroxide, making soap in the extraction of aluminium, amongst many other things. It's a classic alkali. Just a couple of points to drive home. When you electrolyze molten ionic substances, the metal will be formed at the cathode. So when it's molten, a metal will be formed at the cathode, always. When you electrolyze aqueous ionic substances, hydrogen is usually formed at the cathode. Hydrogen, usually. If there's more reactive metals involved, if there's more reactive metal ions in solution, hydrogen will be formed. So it's almost always hydrogen, with a few exceptions, which we'll mention. If you've got compound or polyatomic ions, they're not discharged. So nitrate, carbonate, sulfate won't discharge. And non-metals form at the anode. Non-metals will always form at the anode, whether it be oxygen or one of the halogens, they will be formed to the anode. Right, read through the pages and answer the questions indicated.